Hey guys, today we're going to do 8.2, the reciprocal function family. Our objectives will be to graph reciprocal functions and to graph translations of reciprocal functions. Transformations of the Transformations of the parent reciprocal function include stretches, compressions or shrinks, reflections, and horizontal and vertical translations. Don't write this down. This is just going to be an introduction. There's going to be a better one later on to copy down. But the general form of a reciprocal function is just having x in our denominator. We would have a vertical stretch or compression at A, just like we have all year. H, opposite of H, remember, is left and right. K is up and down. A is also whether or not the graph is reflected on the x-axis. In the graph, we show the function y is equal to 1 over x, which is the reciprocal parent function. Graphing an inverse variation function. What is the graph of y is equal to 8 over x when x does not equal 0? The reason x cannot equal 0 is because if we plug in 0 for x, we will get an undefined value. So therefore, we are going to have what is called an asymptote at 0, at x equals 0, and at y equals 0. Those come from the horizontal and vertical translation. So if we're not translating horizontally and vertically, we have asymptotes at x equals 0 and a horizontal asymptote at y equals 0. So you would make a table of values, plot the values, and then just show the graph. We would connect with a curved line. And when we're picking x values, pick values that would go into 18 easily. So that's why we picked negative 16, negative 18, negative 4, negative 2, negative 1, and so on. Once we connect the points, just like I was saying, there is no x-intercept and there is no y-intercept because we have asymptotes. The x-axis is our horizontal asymptote, and our y-axis is our vertical asymptote. Once we find out our asymptotes based on our shifts of our graph, so h and k, then we draw those and then we can get the basic shape of the graph. We can see that our domain, so left to right on our x values, is all numbers besides x equals 0, and the range, so down to up, is all numbers except y equals 0. Identifying the reciprocal function transformations. Given a value of a, how do the graphs of y is equal to 1 over x and y is equal to a over x compare? What is the effect of a on the graph? So we're just taking the a value and plugging it in for a. Y is equal to 6 over x. And if a is greater than 1, this is going to be a vertical stretch. Y is equal to 0.25 over x means that 0.25 is a, so that's between 0 and 1, so this is going to be a shrink. And when we have a negative, we have to think that we are going to reflect the x-axis, and we will have a vertical stretch. This is what you should write down. Our reciprocal function family. Our parent function is y is equal to 1 over x, where x cannot be equal to 0. A vertical stretch is when the absolute value of a is greater than 1. A shrink is when it's between 0 and 1. Reflection is if we are negative. translations H is on the bottom with X, and it's always minus, so that's when we have to think the opposite. So if it's positive, we would be going to the left, and if it's negative, we would be going to the right. K is our vertical shift, and that is up and down. If K is positive, we're going up. If K is negative, we are going down. Vertical asymptote is X is equal to H. But we have to remember that it's the opposite of H, always, because it's X minus H in our formula. And the horizontal asymptote is Y is equal to K. So this is the whole transformations, all the transformations combined. Graphing a translation. 1, we are going to draw the asymptotes. So I look at X plus 1, that means H is, H is equal to negative 1, and K is equal to negative 2. Therefore, our vertical asymptote is at negative X equals negative 1, so I'm going to go to X equals negative 1 and draw a dotted line. Then I'm going to go to our horizontal asymptote, which is negative 2. So I'm going to go down 2. Since nothing is reflected, I know that it's going to be in the left and the first up here and down here. I know that if I have the parent function y is equal to 1 over x, I can translate those points to get to the left 1 and down 2. So I'm going to think about what points I have for here. So if I plug in negative 1, I would get negative 1. Therefore, I'm going to take negative 1, and go left 1, down 2. And make a point. And then I'm going to approach both asymptotes. Same for 1, 1. 1, 1, I would start here and go left 1 and down 2. So that would be my translation, and I'm going to approach, once again, both asymptotes with a smooth curve. And that is our sketch of y is equal to 1 divided by x plus 1 minus 2. Writing the equation of the transformation, we have to look at first our asymptote. Our asymptotes are at negative 3 and at 1, 2, 3, 4. So we have to go up 4. And since it's negative 3 is going to be positive 3, so that would be our equation for the graph provided. You guys try these 3 problems.